Welcome to my new calculus channel. My name is John Gabriel, and you'll recall, excuse me, in my last video I discussed what is a rate, and I wasn't feeling that great. In fact, I'm not feeling that great now either, but time is of the essence, so I march on. So at any rate, excuse the pun, I discussed the concept of rate in terms of time. And I showed you, and just let me close this window so I can continue. I showed you that time is in fact a ratio, and it's really a special kind of ratio. Basically a ratio that states that 460 meters covered by the Earth is 1 second. Now, we didn't have to define time this way. We could define time in many other ways, but there is a common thread in any definition of time, okay? It doesn't matter which definition of time you choose, there is a common thread. And what is that common thread? Well, you need two things. You need the existence of matter or a physical universe and events. Now, events which can be noticed by constant and repeatable action. And what is constant and repeatable action? Something like cesium atoms vibrating, or a clock which is calibrated to work according to a certain body's motion, or radioactive decay. So, for example, you could, if time hadn't been discovered from the Earth's motion, we could have said that the decay of mass is a way to measure time, and then we wouldn't be saying how long is it, because distance or time is defined in terms of distance. We'd be saying how heavy, because we'd want to see how much weight has been lost from the substance emitting atoms, right? So it becomes if it's radioactive, it emits a certain amount of atoms, it loses mass. And so nothing in the universe, by the way, has constant and repeatable action. Einstein was wrong that light travels at a constant speed. It's more or less constant, but it's not exactly constant, okay? And the same thing with the Earth's motion. And of course, Einstein made some terrible mistakes. His relativity theory is a whole bunch of rot. And the GPS clock anomalies can be described in terms of the fact that the Earth doesn't rotate constantly. In other words, it doesn't have a fixed speed, all right? And so this article here that you see on LinkedIn describes all these things. And you can see that the motion of the Earth is more or less constant, but is not constant always. And this is why we're having to adjust our calendars, our clocks, and why sometimes the clocks in space don't actually correspond exactly to our clocks here on Earth. It's got nothing to do with space-time. That's a garbage concept. That crippled moron Stephen Hawking knew nothing about mathematics and much less about physics. Now, Einstein was the father of all theatrical physicists, and it's a real shame. But at any rate, I don't want to spend too much time on this. Time is not any of these definitions that you see here, certainly not the rubbish that you find on Wikipedia or on university sites or anywhere else. Time in physics is defined as I've explained to you here in my video, okay? So, for example, if you cover 100 meters per second, you're actually looking at 0.21739 approximately Earth seconds, okay? So that's how fast you're going. Now, obviously, you need two things, as I said, and you all know what those two things are. You need existence of matter and constant repeatable motion. Not just motion, but constant repeatable motion, all right? So now there's another thing I'd like to discuss in this video, which is not entirely related but indirectly related, and that is the concept of equivalent fractions, okay, or rates, because really the mainstream academicians or academics, whatever you want to call the morons, don't understand what are equivalent fractions. They don't even understand what is number. So now you'll notice that many will write a half is equal to 2/4, right? And you'll say, well, that's correct. Well, it's only correct if you're looking at it in terms of the abstract unit. And these rates here, there is a subtle difference in these rates. There's a subtle difference in both these rates. The difference is that in this rate here, we are measuring with 2 equal parts of the abstract unit, okay? And in this rate here, we're measuring with 4 equal parts of the abstract unit, okay? So we're measuring with 4 equal parts of the, so that is the subtle difference between equivalent ratios. And this would also explain, for example, why 1 kilometer is equal to 1,000 meters, okay? So the units, the physical units in this case here, are different. This quantity, this rate, which is 1,000/1, is measured in terms of meters. And this quantity here is measured in terms of 1,000 meters, okay? So that's what the subtle difference is between equivalent fractions. Yes, if you're looking at an abstract unit, they're exactly the same. But if the unit is a physical unit, then you know, you can find many equivalent fractions by simply adding the numerator to itself and subtracting the numerator from itself. So take, for example, 3/4. We could just simply say 3 plus 3 plus 4. Now 6/8 is an equivalent fraction. 9/12 is an equivalent fraction. And of course, if I had to start with 9/12, I could do the reverse too. I could subtract 3/3 and get back to 3/4. And if I did this, I would, I'm sorry, that's 4, 4, and 4. I would get to this nonsense here, okay, which means that I'm no longer dealing with a number. And the fact that any well-formed rational number can be reduced to this form shows that Newton's bogus calculus is incorrect, because if you look at the finite difference limit, this pathetic piece of crap which you learn about in mainstream calculus, this thing here is never reducible to 0/0. And yet, ironically, the damn morons in mainstream academia think of the ultimate ratio as what happens when this approaches this particular form, okay? And obviously 0/0 is just a bunch of crap. So at any rate, this is what I want to excuse me, what I wanted to cover in this video. And just to close off, I encourage you to download my free ebook and study it. If you want to be a mathematician, you have to learn how to develop well-formed concepts and to realize well-formed concepts. If you start off with a false concept, everything you build on it will not be reliable. And at some or future stage, your theory will become so overwhelmingly complex that it will collapse on itself, being filled with thousands of contradictions. In other words, your ill-formed concepts will really lead to theory that is unreliable. Okay, so I encourage you to avoid nonsense like set theory, first-order logic, and real analysis. Anything to do with the study of logic in mainstream mathematics is a bunch of crap. And don't waste your time on it. Study calculus because calculus is useful and you can do very much with it. With the rest of that garbage, there's nothing you can do with it. There is no AI, only advanced automation. And if it uses set theory, it's bound to have problems, as we've seen in many of the recent applications with self-driving cars, etc. So we cannot rely on ill-formed theory, and I encourage you to study my free ebook and to watch these videos and to spread the news of this channel. And hopefully, when I'm feeling a little bit better, I'll produce better videos. But I think to myself that if I don't get this video out, there's a chance I may never get it out. So I hope you've enjoyed this small presentation, and I will keep my videos under 15 minutes, or try to. So until next time, this is the New Calculus channel. I'm John Gabriel. Goodbye.